In this video, we are going to look at the difference between degree and radian measures, how to kind of flip back and forth between those, and then also determining coterminal angles. So one thing that you need to realize is when we do define any kind of angle, you have an initial side, and then the angle opens to the terminal side, and then that angle has some type of measurement. We call that sometimes theta, sometimes alpha, and we give it a Greek letter to name the inside measure of that angle. 1 degree measure is 1 out of 360 because 360 degrees goes all the way around for any angle. And what we're going to be doing is we are going to be putting our initial side in line with our x-axis and then opening this terminal side so that you have that angle measure there. We call that standard position. If you do have a 90-degree angle, note that that's going to be the y-axis. And so any acute angle or angle less than 90 degrees is going to be in quadrant 1. Any angle between 90 and 180 will be in quadrant 2. Between 180 and 270 would be in quadrant 3. And then between 270 and 360 would be in quadrant 4. For the purpose of the next couple of videos, we're only going to really be looking at quadrant 1, but it is important to understand that positive angles go counterclockwise, so go from the x-axis and then turn in favor of the y-axis. And if you have a negative angle, like maybe theta equals negative 30 degrees, then you actually go in the opposite direction. So you have your terminal side, and then you would go in the clockwise direction, that angle measure. And so right here, if I wanted to sketch a positive angle of 30 degrees, I would have my initial side, and then my terminal side, I would make sure that that angle measure is 30 degrees. If I wanted to have an angle of negative 135, I have my initial side. Now here would be negative 90, and this would be negative 180. And so I know negative 135 would have to be somewhere between those two numbers. Negative 135 is 45 degrees more than negative 90 degrees. And so I could make a 45 degree, like an extra 45 degree angle here. And we would say that that angle measure is negative 135. We also need to make sure that we talk about radians. So radians have to deal with a different unit of measure for our angles. To find this other unit, we need to think of how circles are drawn, and if you wanted to stop that circle before it's completed. So very similar to what we were doing up here. Radian measures then deal with the arc length that is created, that's that piece of the circumference. So if I have a circumference, which is 2 pi r, and we divide both sides by r, then we know that the ratio of the circumference is always 2 pi with regards to the radius. Let's write that. So you can even write this over 1 if you want to think about it as a ratio. So the circumference is always 2 pi larger than the radius. This brings us a new angle measure that's in terms of pi versus in terms of degrees. So we will say that one rotation around the circle, which would be 360 degrees, if that radius is 1, then the circumference of that circle would be 2 pi. So we call that 2 pi radians. If I just go to pi radians, then that's the same as 180. And then 1 radian in this measurement is like 57.3 degrees. Now, what radians actually measure is that this distance from the center to the side, the radius. And then that same measure, if you were to take like a flexible tape, would be the same as this arc length. So it's the ratio between the radius and the arc length. Now, because of that, radian measure is completely dimensionless because these would have the exact same unit of measure. So you would have the length and then the circumference. And so when you're looking at the ratio between them, we would sometimes call this radian, like this. But you really don't have to. You can just say like, oh, it's 2 pi. Now, if I want to convert back and forth, the way that I'm going to do that is through this proportion right here, or the fact that just 80 is equal, or 180, excuse me, is equal to pi. In this example, we won't go through each and every one of these, but some of them that are really, really common, like 30 degrees. So if I say I have 30 degrees, and I want that to be the same units as 180 degrees, then that's my angle in radian measure over pi, or that proportion of 30 out of 180 has to be the proportion of whatever that length is here, that arc length is, with respect to pi. Well, I end up getting 1/6 here, and then I multiply pi over. And so a very common radian measure is pi over 6 for 30 degrees. I can do that same thing, but let's do it for 135. So if I have 135 degrees out of 180, if you end up simplifying this here, you end up getting 3 over 4. I then bring my pi over, and we see that this radian measure on our unit circle, or on our circle of radius of 1, I should say, is going to be 3 pi over 4. All right, let's do one more. Let's do 300. So I would set this up as 300 over 180 equals theta over pi. When I simplify here, both of these are divisible by 60, so I end up getting 5/3, and then I bring the pi over, or 5 pi over 3, if I want that in terms of radians. All right, the last big chunk of information that I want to make sure that we go over is coterminal angles, meaning that the terminating side is the same whether you go in the clockwise direction, or excuse me, the counterclockwise direction, the clockwise direction, so this is counter, this is clockwise. Or even if you were to go around once and then hit that angle again. The big thing is you want to make sure that you're able to take any angle and get it to be between 0 and 360. So if it's a negative angle, what is the positive on this range of numbers? If I want to look at trying to figure out where 800 is in terms of 0 to 360, then what we might want to do is divide that by 360s. How many 360 rotations does this have? Well, 360 times 2 would be 720. So I know that this would go around twice to get to 720, and then there would be 80 degrees left over. So that coterminal angle, there's no like official way to do this. So we'll say like the coterminal angle would be 80 degrees. All right, let's do this in radians as well. So remember on our circle, this is pi to get to 180 degrees. This is 2 pi to get to 360 degrees. So if I divide here, 19 pi divided by 4, that goes around 16, right? 16 would be 16 pi, and then 3 more over 4. So let's see, that would be 4 pi, and then I would maybe write this as 3/4 pi. Now what the heck does that mean, right? I need to go 4 pi rotations. So 1, 2, 3, 4 pi rotations, and then a 3 pi over 4. Well, if this is pi, those would be pi over fourths. And so that would be the coterminal angle there at 3 pi over 4.